Hello, I'm Ioana, a senior data scientist, and in this video I'll share with you which are the questions that I ask when interpreting scatterplots. We build scatterplots when we want to discover relationships between two numerical characteristics. Are people spending more as their income increases? Does the rainfall amount impact the number of car crashes? These are all valid questions that can be visualized with a scatterplot. In data science, these characteristics that we measure are called variables. Their association is called correlation. Scatterplots can look very different in terms of the direction of the cloud point, which can be ascending or descending. In terms of the shape the point cloud follows, linear or nonlinear, and in terms of the dispersion of the points, or how wide is the point cloud. When interpreting a scatterplot, we answer the following questions. Are the variables correlated? Is there a pattern at all? And if yes, how strong is the correlation? How wide is the point cloud? Is the correlation positive or negative, linear or nonlinear? Are there any outliers, points that fall away from the point cloud? An example of a linear positive correlation is the more effort I put in studying for my exams, the higher the grade. More effort equals a higher grade, less effort, a lower grade. Or a small number of hours result in a small grade, whereas a high number of hours results in a high grade. An example of a negative correlation would be the later I wake up in the morning, the less time I dedicate to getting in shape, like in the middle plot. When there is no pattern indicating a correlation, the two variables are unrelated. For example, the height of my friends and their salaries. One of my goals this year was to get in shape. So, every day I logged my wake-up time and the number of minutes of intense physical activity. The statistical way to think of this is, will the amount of physical activity depend on my wake-up time? The amount of physical activity is going to be the dependent variable or the response. The wake-up time will be the independent variable, also called the predictor. Just by looking at the numbers, I don't get much information, but a visual representation would be more informative and powerful. The predictor always goes on the horizontal axis and the response on the vertical axis. We mark the values on each axis according to the values recorded in the table and start to pair them up one by one. So there I have my answer. In my case, waking up earlier helps me get fit. Scatterplots come in different flavors. For example, one can add a third characteristic to the scatterplot, such as scoring my energy level on a scale from 1 to 5 and draw the size of the bubble according to the score. A large bubble would mean a higher level of energy and a small bubble a lower level of energy. This way I can identify my optimal waking window, which helps me stay in shape and have at the same time a good level of energy throughout the day. I can even ask two friends to join the challenge and check if their behaviors in terms of sports are similar to mine. What is the question you would like to answer with a scatterplot? Here are some exercises for you, so pause and think for a moment, and then let's see if you got it right. In the first scenario, we can think the number of members in a family would influence how much money goes into purchasing food. So the dependent variable is the cost of food in dollars. For a real-life project, we could consider the monthly cost. The second scenario could test the hypothesis that the light traffic early in the morning could help me save on fuel, as I don't spend so much time stuck. The fuel cost would depend on my waking time. Pause the video once again and try to describe the relationship between each pair of variables. The upper left corner displays a scatter plot indicating a linear correlation because the points follow a straight line. It is a positive correlation because the direction of the point cloud is increasing, and it is also moderate. In the upper right corner, the correlation is also linear because it follows a straight line. It is positive because it is increasing, but it's much stronger than in the previous plot because the dispersion of the point cloud is very close to the imaginary line that we draw through the point cloud. In the bottom left corner, the points indicate a non-linear correlation because here the points do not follow a line, but more of a curve. It is also positive because the direction is increasing. It is strong because the points are not very dispersed from this imaginary curve. And moreover, it also shows that there is one outlier. The lower right plot indicates a linear correlation, but this time it is negative because the direction of the points is decreasing, and it is also a strong correlation because the points are close to the imaginary line. It indicates the presence of two outlier points. I hope now you know more about scatterplots. Don't forget to subscribe if you found this video useful, and hope to see you next time.